So far we have been seeing about calculus. In this we saw about limits, continuity, and then we went to differentiation, and we saw the Rolle's theorem, mean value theorem, and finally we came to L'Hopital's rule. These are the things we have seen so far. Now, having understood all these things, let us see the application of derivatives, application of differentiation. This is what it is, because these results are, there are many mathematical results published, but unless and otherwise we are unable to apply it in our physical world, it is of no use. And whenever application comes into picture, engineers are very good in applying, so we should understand the applicative points of each and every result where we can apply the results. So first thing we are going to see differentiation. What it gives me? Rate of change. This we have seen already. That is, rate of change means it gives me speed. That is, speed is nothing but d by dt of distance, correct? And similarly, if I do this, I get acceleration, correct? Acceleration is nothing but d by dt of speed, and this is nothing but d square by dt square of distance, correct? This is in physics. This is with respect to mechanics. We have seen this. This is not only applicable here. I can find any rate of change here. For example, if you want to see how the stock prices are varying, I can take the prices of various shares and see how they are changing, and I can see the rate of change of share market prices. Rate of change of stock prices. Stock prices can be popular. This is a very useful factor in investments. This is one very good application. Similarly, I can find the rate of change of population. I can find rate of change of some quantity, which will give me the many other advantage in understanding the system. Clear? Okay, this is the first application. Second application is what? Slope of a curve at a point. At a point. So what do I mean by this? How differentiation is able to give me slope of a curve? Let us see. What do I mean by a slope of the curve at a point? What do I mean by that? And slope of a curve at a point, also what it is? It will also give slope of tangent to the curve at a point. This is more important. Fine. What do we mean by that? So let us take any arbitrary curve. Okay, say this is my f of x. This is an arbitrary curve we have taken. This is my x. This axis is f of x. Y equal to f of x. Okay. Now, what do we mean by this? Say for example, what do we mean by tangent? First, let us write this. Tangent is what? Tangent is nothing but a line that cuts the curve at only that point. That cuts the curve only at that point. Correct? That means if I draw the tangent at here, it will look something like this. It will meet the curve only at this point. Correct? Okay. Now how do I get this line? How I got this line? This is the tangent. Okay. And this is the curve. Correct? How did I get this line? Okay, now let us say in a iterative procedure how I got that line. Okay, the curve was like this. I was to find the tangent at here. Now what happened? Let me draw a line like this. Let me draw different lines. Okay, so the first line I am drawing is like this. Okay, now what is this? This is some value. Say let me call this as this is my f of x, and let me call this as line L1. Okay, this meets the curve at B1 A1. So I can find f of B1 minus f of A1 by B1 minus A1. This we have been talking from the first class. What is this? This is nothing but average change. Correct? Now I want to find the instantaneous change. What is instantaneous change? I keep on coming close and close and I find the change only at that point. That is only at say any point like this. At a particular point I find. Okay, let me take another line now. Let me move closer to this point. So now I take another line which is like this. Now I take a different line like this. Okay, now this line cuts the curve at A2 and B2. Now again I can find what is f of B2 minus f of A2 by B2 minus A2. Now I can keep on doing this and converge towards this point. At that time what I will get? I will get this line, and that happens to be the tangent. And now if I evaluate, if the curve it is cutting the curve only at one point, I can say that if I put a zoom here, it will look like this. It is cutting like this. This is the curve, this is the line. So you see it cuts at a small thing, and this is very close to 0. Correct? That is, if I call this as h, if I call the gap here as h, what I am trying to do here, if I go by this formula and write this here, what will I get? I will get f of x plus h minus f of x by h, and h is what? H is tending towards 0. And what is this? This is nothing but f dash of x. So f dash of x at a point will give the slope of tangent to the curve. This is a very important result, because this is nothing but the instantaneous change of the f of x and the instantaneous change of the tangent at this point are same. Correct? So slope of curve at this point, if I evaluate, slope of curve equal to slope of tangent. This is a very important and powerful result. So let us quickly enhance our understanding on this point. So what we saw just now, f dash of x will give slope of curve, and f dash of x, if I am evaluating at a point, it will give me slope of curve at that point, and slope of curve will be equal to slope of tangent to the curve at that point. Correct? This is a very useful result in analytical geometry. Okay, let us quickly solve the problem and check this out. Okay, find the equation of the tangent to the curve x cube plus y cube well, sorry for this. Okay, let us check. Y is equal to x plus 2 by x. Find the equation of the tangent to the curve y is equal to x plus 2 by x at 1, 3. This is the question. How to proceed? Solution. See, we will take one by one. So first we need the equation of the tangent. We know that tangent is a straight line. Correct? Tangent is nothing but a straight line. So now I need the equation of a straight line. Equation of a straight line can be found if slope of the line and one point is known. This is called slope point form, right? If slope and one point are known, I can find the equation of a straight line. The one point is already given here. All I need is the slope. If I find the slope, I can find the equation of straight line. What is the slope point form? Y minus y1 is equal to m into x minus x1. This is called the slope point form, right? Slope point form of a straight line. This is what we are going to use. This is the concept we are going to use. So now I have to find the slope. So ultimately question boils down to find the slope. And what is slope? Slope is nothing but y dash. That is nothing but dy by dx. What I have to do? Dy by dx. That is nothing but dy by dx. If I have to find, I have to differentiate the given function. That is x on differentiation will give me 1 and 2 by x on differentiation will give me minus 2 by x square. How? Because 2 by x is nothing but 2 into x power minus 1 and x power minus 1 on differentiation will give me 2 into minus 1 x power minus 1 minus 1, that is nothing but minus 2 by x square. Correct? I am substituting the result here. So dy by dx is nothing but 1 minus 2 by x square. This is the dy by dx. Now at 1, 3, dy by dx is what? 1 minus 2 by 1 square. This is nothing but minus 1. So this is the slope at that point. Therefore, equation of tangent to the given curve at 1, 3 is y minus y1, that is 3, because the point is x1 y1, right? So this is x1, this is y1, 3 is y1, x1 y1. So 1 is x1, 3 is y1. Y minus y1 is equal to m we have found to x minus x1. So we will, on simplification, we will get as y is equal to minus x plus 4. This is the solution. Okay, let us solve one more problem. Here it is a little bit different one than the previous. The function is similar. Find the equation of normal to the tangent for the curve y is equal to x plus 2 by x at 1 comma 3. In the previous case we solved the tangent. Now it is asking the normal. So again equation of normal is asked. Please remember, it is not the equation of tangent, it is the equation of normal to the tangent that is asked. So what is the relation? Now we will go to the basics of coordinate geometry. Basics of coordinate geometry we should remember. Coordinate geometry. What do we know? First thing is one point form of equation. Slope point form of equation, that is y minus y1 is equal to m into x minus x1. Second point is what? m1 into m2 equal to minus 1 if two lines are perpendicular, where m1 is the slope of line 1, m2 is the slope of line 2, and if line 1 is perpendicular to line 2, line 1 is perpendicular to line 2, then m1 the slope of line 1 into m2 the slope of line 2 will be minus 1. This is a very important concept. So what is the relation between normal and tangent? Same thing. Normal will be perpendicular to the tangent. Correct? Now if I can calculate the slope of tangent, I can calculate the slope of the normal. I already know one point, that is 1 comma 3. This is the given point. Using the given point and the slope, I can find the equation of normal. Correct? So first, now the problem solution starts with find the slope. Find the slope of what? Find the slope of normal. But I cannot find the slope of normal directly. For finding the slope of normal, find the step-by-step process. We can easily solve the problem. Find the slope of tangent. And how do I find the slope of tangent? This is nothing but dy by dx at that point. And the given equation is y is equal to x plus 1 by x, 2 by x. So dy by dx will be 1 minus 2 by x square at 1 comma 3. Dy by dx will be equal to minus 1. Therefore, what will this minus 1? This is the slope of tangent. Correct? Now, slope of tangent into slope of normal will be equal to minus 1. Why? Because normal is perpendicular to the tangent. Since normal is perpendicular to the tangent, slope of tangent into slope of normal will be equal to minus 1. Okay? So, slope of normal will be equal to minus 1 by slope of tangent, that is nothing but plus 1 now. Therefore, equation of normal will be what? Y minus y1, that is 3, is equal to 1 into x minus 1, that is nothing but y is equal to x minus 1 plus 3 implies y is equal to x plus 2. This is the solution. Okay, we were basically discussing about the application of derivatives, correct? We first started with application of derivatives, correct? This is what, or differentiation. This is where we started the discussion, correct? The first was rate of change. Second was equation slope of tangent, and from this we were extrapolating to equation of tangent and normal. Tangent I am writing in short form here, TGT. Okay, equation of tangent and normal. Then third important one, this we have already seen. We can find maximum and minimum values of a function. That is, at, we have already seen this, right? At max or min value, f dash of x will be 0. At max or min, not value, at max or min point. And how do we conclude that it's a maximum? At max, if it is a maximum point, f double dash of x will be less than 0 at that point. If it is a min value, f double dash of x will be greater than 0 at that point, correct? This we have already seen. Let us solve examples, and we have already seen the examples for maxima and minima. Let us take one more example and strengthen our understanding. So let us take this example. F of x is equal to square root of 4 minus x square. Find the maxima or minima point in interval -2, 1. Hence, find the maximum or minimum value of f of x. This is the question. The question is to find the point where the maximum or minimum is occurring, and hence he is asking you to find also the maximum or the minimum value of that f of x also. So basically we have to find what is the value of x, that is, this is at what x, f of x is max or min, and this part is what is that max or min value of f of x, that is this part. Okay, so basically we go back to the derivatives again. So fine, so what do we know for max point? Let it write it again, we will get it practiced. Our min point, we have f dash of x equal to 0, but for a max point we will have f double dash of x less than 0, and for min point we have f double dash of x greater than 0. This we have seen. So let us find first what is f dash of x. What is f dash of x? Here, what is f of x first? F of x is nothing but 4 minus x square the whole power half, correct? Square root I can write like this. So what is f dash of x? Here I have to apply chain rule and solve. So first I will differentiate f of x completely, then I have to go and differentiate x square. So f dash of x will be 1 by 2 4 minus x square the whole power 1 by 2 minus 1, because n x power n minus 1, right? Derivative of what rule we are applying? Derivative of x power n is equal to n into x power n minus 1, correct? D by dx of x power n, correct? So this is the relation we are applying. Okay, so based on that we get simply upon simplification this will give me 1 by 2 sorry, this itself is not complete, right? Let me rewrite it clearly. F dash of x will give me 1 by 2 4 minus x square the whole power 1 by 2 minus 1 into I have a x minus x square. It is not x square, it is minus. Please pay attention to this minus sign, minus x square. So that on differentiation will give me minus 2x. That whole term will simplify as this 2 and this 2 can be cancelled. The whole term will simplify as minus x divided by root of 4 minus x square. Now what is the condition? F dash of x will be equal to 0, implies minus x by root over 4 minus x square will be equal to 0. This will imply x equal to 0. So x equal to 0 is the point. Now we know this is either maximum or minimum, but we don't know with confidence whether it is maximum or minimum. We don't know, but one among the either that we know for sure. So we have to confirm. How do we confirm? We find f double dash of x is nothing but f dash of x the whole dash. That will give me what? I have to differentiate this now. I can apply quotient rule, correct? So I will get 4 minus x square within root the whole square, then root of 4 minus x square into minus 1 minus what? Minus x into 1 by 2 root of 4 minus x square derivative, right? I have to differentiate this. That is the whole power minus 1 by 2 I will get if I differentiate into minus 2x, correct? This is what I will get if I apply quotient rule, correct? This is minus x. This is what I will get. There is no root over here. Okay. Now I have to check f double dash of x at x equal to 0. The moment I substitute x as 0, I am multiplying by x. So this f double dash of x will become 4 minus 0 within the root into minus 1. I have a minus x multiplied by this whole term, correct? So this whole part will become 0, minus 0, because x is taking the value 0, divided by 4 minus 0 the whole square. This whole, what I get, correct? Now 1 4, this is root of 4 minus 0, this is 4 minus 0 the whole square. So one thing I can cancel it here, one thing will get cancelled, so I will get minus 1 by root 4. This is less than 0. So at x equal to 0 we have maximum value, and what is that value? We have to substitute back. So f of x will be root of 4 minus 0 square, that is nothing but 2. This is the value.